Hey everyone, this is 14.2, Measures of Central Tendency. Um, Keep in mind one of the big goals of statistics is to take a large set of data and to try to make some sense out of it, to try to organize it, try to figure out things like, where is the center of my data, or how is my data varying, what's the distance between my data, and stuff like that. So in 14.1, we tried to find ways to just organize it visually rather than just working with the raw numbers. And here in 14.2, we're going to be focused on the center of our data. And this isn't really well defined, which is why we have three different ways to measure the center. But in all of these, we're trying to get an idea of where is most of my data sitting, or what is my most frequently occurring data value. Different ways we can try to get an idea of the middle of the data. So the first one is mean, which is essentially an average. And luckily, we all know, or most people know how to find an average. This is kind of a new way of looking at it, though. This is a pretty formal definition of an average. So the first thing is, this is the symbol for average. It's an X with the bar over it. I often call that X bar. And it says the average or the mean equals. This symbol is a Greek symbol called capital sigma. And in math, what it means is add them all up. So when you see sigma x, it means add up all the x's. And x's are just standing for the data values in your set right now. So that's good. That's exactly how we think about the average, right? You add up all your values and you divide by how many there are, which is n. N just stands for the number of values. So this is a pretty maybe scary looking math definition, but keep in mind it's just a regular average. Add them all up, divide by how many there are. So mean is one measure of central tendency that we'll use. Median is the next one. For the median, you need to arrange the data in order. This can be either increasing order or decreasing order. And then you're going to pick out the middle value. Now, if you have an odd number of values in your data set, then there will be one exact middle value, and that will be your median. If you have an even number of values in your data set, that means there's going to be two values in the middle. There won't actually be a single middle value. So you're going to take those two middle values and average them, which just means you add them together and divide by 2, and that'll give you your median. And lastly, we have mode, which is simply the most frequently occurring value. So whatever value in your data set that shows up the most. Now, there are some catches here. There's kind of three cases you can have. If you have one value that just shows up the most, well, great. That's your mode. Easy. Sometimes you have a tie between two values. So maybe you have two values that show up, like 3 times, and all your other values only show up once. Well, now you have two values that are tied for being the mode. So you literally have two modes. That's okay. Now, if you have a tie between anything more than two values, we just say there's no mode. So you can't have 3 modes, you can't have 4. This also covers the case where if all of your values only occur once, well then technically they're all tied for the most frequently occurring, right? Obviously, we're just going to say no mode in that case as well. So your 3 options are 1 mode, 2 modes if there's a tie between 2, or no mode if there's a tie between more than 2 values. Let's do a quick example here, finding the mean, median, mode. This is on page 723 and number 2. So we have a short little data set here, I think 9 values, the 8, 9, 4, 2, etc. And we are going to calculate our mean first. So I wrote the formula for you. Remember, x bar just stands for the mean, and the formula is the sum of all x's divided by n, which is how many values there are. So I did this very easy math for you already. If you add up all the values here, the 8 plus 9 plus 4 plus 2, etc., you should get 49. Oops, wrong color. 49, and then when you divide it by how many values there happen to be 9 values in this data set, so you divide it by 9. And then throw this in your calculator. We'll go and round it to 1 decimal place. 5.4. That is our mean. We'll talk about these all when we get them together, but let's jump on to the median. Remember, for the median, you need to arrange your data in order, either increasing or decreasing. I decided to do increasing, so 2 is your smallest, then you have your 2 3s, 4, etc., etc. So our data is in order, and now we have 9 values, so that's odd. So notice we have 4 on one side and 4 on the other. So the value right in the middle is 5. That is our median. And then lastly, mode. Mode is the most frequently occurring value. Well, in this case, it looks like we have 2 3s and 2 5s, and everything else occurs once. So like we were talking about, we have a tie for the most frequently occurring, a tie between two values. So our mode is going to be two numbers, 3 and 5. Right, so we have our mean, our median, and our mode. Notice mean and median are pretty close, which they usually are, not always, but they're both trying to give you an idea of what value is closest to the middle. So 5 is a pretty good guess here. 5 is also one of our modes. The 3 is the mode. That doesn't really show you as much, but it does show you kind of, that it's one of the more frequently occurring values. But all of these are trying to give you a different picture of kind of what's in the middle, what's the average. The other thing to notice here is that the mean is 5.4. Notice 5.4 doesn't show up anywhere in our data set. So often your mean will be a value that's not actually in the data set. Your mode, by definition, have to be values that are in your data set. And our median happened to be 5, which was in our data set, but sometimes if you have to average it, sometimes also for median, you get a value that's not in your data set. So keep in mind, these statistics are numbers that aren't always values that are actually in your set. Alright, so on page 723, number 14, they want us to find the mean, median, and mode again, but this time they're giving us a frequency table instead of just a list of data. So the frequency table is over here on the right. Don't forget how this works. The x's are the values that are in our set, so for example 2 is one of the values, and the f's are the number of times they occur. So this first line means the value 2 occurs 3 times, so there's 3 2's, and then the value 5 occurs 2 times, so there's 2 5's. You could actually, and in fact we'll actually do this later on the calculator, you could just take all this data from the set and list it all out. Well, there's a lot of values here, so it's not something you probably want to do. But keep in mind that is one way to tackle this problem, is just to take the frequency table and basically pull all the data out and just make a big list. Kind of going backwards from the problems we did in 14.1. But we're going to do it while it's still in the frequency table, and we're going to have a slightly new formula over here for our mean. So if you have a frequency table and you want a mean, this is the formula you use. X bar, still your mean. This time it's the sum of all the x times f's divided by the sum of all the f's. Well, x times f, remember up here, in general when we find the average, we're going to add up however many values there are and divide, we're going to add up all the values and then divide by how many there are. So when you go up to this data set, there's 3 2's, right? So you do 2 plus 2 plus 2. Well, notice that's the same thing as 2 times 3. And down here you have 2 5's, so it would be 5 plus 5. Well, that's the same thing as 5 times 2. That's why they have this x times f. If you just take your x and multiply it by the f, your next one multiplied by the f, etc., that's the same thing as adding up all of your data values. And obviously the sum just means you take that times that and add it to that times that and add it to that times that, etc. That's what I've done for you in this first line up here in the numerator. It's each of the values multiplied by their frequencies added to the next. And this will be the same thing as adding up all of your data values. So it still is the same thing as mean, we just have to be a little bit tricky about it. And then we want to divide by how many values there are. If you have a frequency table, the frequencies tell you how many of each value there are, right? So 3 2's, 2 5's, etc. So there's 3, 2, 3, 2, 1, 5, 2 different values. And if you add all these up, that'll tell you how many values there are. That's what sigma f means. It means add up all the frequencies. And that's what I've shown down here. These are all the f's just added together. So again, this does give you the same thing as mean before. This is the sum of all the values divided by how many values there are. And if you do this calculation, let's see if I did it right, you should get 134 on top. So the sum of all the values is 134. And the sum of the frequencies should be 18. So there's 18 values in your data set. And then again, throw it in the calculator. This should give you about 7.4. Alright, so that's the formula you use to get a mean if you have a frequency table. Let's look at median. So median can be a little bit tricky from a frequency table. The good news is it's already arranged in ascending order, right? We're going from smallest to largest. Now, what we have to figure out, first of all, it's good that we did the last problem because we know there's 18 values, right? There's 18 total values. And since that's even, we know that when we're finding median, there's going to be 2 middle values. And in fact, if you split 18 in 2, you get 9, right? So that means the 9th value and the 10th value are going to be the 2 middle values that we're going to end up averaging together. So the tricky part is figuring out what is your 9th value and your 10th value. Well, if you go through this, there's 3 2's, right? Then there's 2 5's and 3 7's. So 3 plus 2 is 5. 5 plus 3 is 8. So right here, this 3, 2, 3, these are the first 8 values. That means the next value will be in the 9th, and the value after that will be the 10th. So right here, this 2, these are two our 9th and 10th values, and they both happen to be 8s. So that's how you figure out where your middle is. Again, since I know there's 18, and I know that there's going to be 2 middle values, that's half of it, which was 9, and the next one will be 10th. I need to figure out what are the 9th and 10th values. So here's the first 3, here's the first 5, here's the first 8, right? And then after that will be the 9th and 10th, and they both happen to be 8s. So over here we figured out our 9th value is 8, and our 10th value is 8. Well, all we have to do is average these now to find our median. So we'll take 8 plus 8 and divide by 2. This is kind of work we don't need to do because when you average a number with itself, you just get that number back. But I just wanted to show you the work. When you get your two middle values for median, this is how you average them. And if they're the same value, well, you just get that value back. So that's how you find a median given a frequency table. First of all, figure out how many values you have, divide it by 2, what is your middle value. If you have 2 middle values, look for both of them, and then count up your frequencies until you get to the 9th, 10th, or whatever value you need, and then average them if you need to as well. Lastly, we have mode, which is the easiest thing to do with the frequency table, because that's literally what a frequency table tells you is, how many times does each value occur. So we're just going to go through our lists and look for the highest frequencies. We got some 3s, some 2s, ta-da, there's our 5, right? That's the highest frequency. That means 10 occurs 5 times. That's the most frequently occurring value. Notice there's no ties or nothing bigger than 5. So 10 is automatically our mode. Nice and easy if you have a frequency table. And there we go. We got our mean, median, mode from the frequency table. Okay, we're going to move on to what's called a 5-number summary and a box and whisker plot. And the way we're going to do this is we're going to use a function on the calculator. So this is problem 724, or sorry, on page 724, number 18. I'm going to talk about how to get to this on the calculator first. So on your calculator, you should have a button that says Stat, and you should be able to press Stat and then go to Edit, and then you should have some lists. And in L1, list 1, what you're going to do is you're going to enter all these data values. So you should be able to go to L1, go to a blank spot in the data set, and type in 21 and press enter, and then that should go in the list. And then type in 24 and press enter, and 15 and press enter, etc. until you get through all this data, right? So you're going to enter each value, and then you should have a nice list of all your data in your calculator. So once you have that, you're going to press Stat again, and this time you're going to use the arrow keys to go right to Calc. If you look at the top when you press Stat, you should have like Edit, Calc, etc. So you want to go to Calc, and then your very first option, I believe, should be one variable stats. And this is great. This will actually calculate a lot of important or useful statistics for us. And depending on what model of calculator you have, once you press that button, it might ask you to like specify what list you want. Well, since we entered our data in list 1, you're going to obviously specify list 1. The way you do this, by the way, is you have to press second in the top left, and then press the number 1. If you look above the number 1, you should see a little L1 in like a different color. So that's how you pick out your lists. If it doesn't ask you to specify, or if it just takes you to a screen that says one variable stats, by default it should calculate it on your list 1. Okay, so before we jump into this, this is some of the things it's going to give you. It's going to give you, when you calculate these one variable stats, it's going to give you a big list of numbers. So this isn't all of them, but these are the important ones. X bar is your mean, obviously, so that is very useful. SX is your standard deviation. We'll see this in the next section. This is a very difficult thing to calculate by hand, and so the fact that the calculator just gives this to us is great, and we will actually be taking advantage of this a lot. N, by the way, gives you the number of data values. This is just a good way to check to make sure that you actually entered all the values and you didn't leave any out. And then there's actually a bunch of things here, so if you have to push down on the arrow key on the top right, and this will take you down to the bottom value, or the bottom statistics it calculates. And these are the 5 that we kind of want to focus on. These are what we call the 5-number summary. And it consists of the min x, which is the minimum value, q1, which is the first quartile, med, which is the median, q3, which is the third quartile, and the max x, which is the maximum value. Now let me talk to you briefly about what these things are. A couple of these are obvious, like the min x is literally the smallest value in your data set. Max x is literally the largest value in your data set. Median we've already talked about. It's just the middle value. Now these quartiles are kind of new, but they actually make a lot of sense. And I drew a picture down here at the bottom to kind of illustrate this. Between your data, your minimum and your maximum, the median sits right in the middle. Now what that median does is it splits your data into two pieces. You have your first half of your data over here and the second half. So if you're just looking at your first half, let's ignore the second half for a second. If we're just looking at this first half, we should be able to find a median of just the first half. And that median we call Q1. So Q1 is literally, the first quartile is literally the median of the first half of your data. And likewise, if we just focus on the second half of the data and we find the median, that is what we call Q3. So notice up here in median I put Q2. The median is actually the same thing as Q2. If you take all your data and split it into two pieces, you get your median, your second quartile. Alright, so we will not be calculating these by hand, although we could easily, right? You just list all your data, pick out the middle one, and then once you do that, look at your first half, you have it listed out, pick out the middle one, and take your second half, you have it listed out already, pick out the middle one. Obviously, if you have like a tie for middle, you average them and all that stuff too. But we won't be doing this by hand, we're just going to let the calculator do it for us. So that's the 5-number summary. And the last thing is, once you have your 5-number summary, it wants you to draw what's called a box and whisker plot. Well, that's pretty easy. You're just going to plot them pretty much like I have down here at the bottom, and then you're going to make a little big whisker on each end, and you're going to label whatever the value is, and then you're going to make a box around your first quartile to your third quartile. And you'll label each of these values where they are too. And it looks kind of silly here. I mean, sometimes it looks kind of silly either way, but what it's trying to show us is just visually, where is my data distributed on a number line, where is it kind of leaning, and where is the kind of the median and the quartiles at. So it's kind of going to give you an idea of where the center of your data is, where your maximum minimum are, and where your center might be leaning towards your minimum or leaning towards your maximum. Your median might be leaning towards the third quartile or the first quartile. It's just another visual representation of your overall data. So now that we know all this, let's go back to our problem and apply it. Alright, so back to 724, number 18. These are our values. We needed to make a calculate the 5-number summary and then draw a box and whisker plot. So again, all you're going to do for the 5-number summary is throw this in the calculator and run your one variable statistics. If you do that, you should get these 5 numbers for your 5-number summary. Again, you'll just arrow down and they'll literally just be written for you. So our minimum value is 15, maximum value is 45, our median is 26, and then the median of the first half, the first quartile is 21, the median of the second half, the third quartile is 41. All you need to do now is slot this on a number line. So I went ahead and just did a generic number line here, starting at our minimum, going to our maximum. So the first thing is, these will be our whiskers. Oops. These will be our whiskers, and we will go ahead and label these values again on the bottom, 15. And our other whisker over here, our maximum value, 45. Alright, so you definitely have to have those on there. And then we're going to go ahead and label the rest of them. 21 will be somewhere around here. There's our first quartile. Our median is 26, so somewhere around here. And then our Q3, which is 41, somewhere around here. Oops. Alright, so you label all these, plot them on a number line, and then draw your box and whiskers. So our whiskers are just kind of the big lines on the sides, and our box again will go around your quartiles. Try that again. There we go. It'll go around your first and third quartile, just like that. That is what we call a box and whisker plot. And so from here you can kind of see that overall our data is leaning a little bit towards the left, like our median is over here towards the left, not quite right in the middle. But then between our median and our first quartile, we have just this little bit of space. So it looks like we have a lot of data kind of in this range as well. So like our center is leaning to the left, but our overall center, like the Q1 to Q3, is leaning a little bit towards the right. And we have our smallest and our largest value. So again, a lot like 14.1, this is just a visual representation of our data to help us kind of tie together what's happening in this data set. So that's your 5-number summary, and this is your box and whisker plot. Alright, last thing here, we're going to do just a couple problems, basically playing around with some averages and some things we can figure out given some averages. So on page 725, number 32, this one says the mean number of hours that Raphael worked over the past 4 weeks is 38.75. If he works 42 hours this week, what will the mean number of hours be that he will have worked over the 5-week period? Alright, so we have a 4-week mean, then he has 1 more week of hours, and now we want to find the 5-week mean, right? So I've set up kind of a picture of what we have from the beginning. They tell us that the mean, his average for 4 weeks is 38.75. Well, how would you find an average for 4 weeks? Well, you would sum up all of the hours for 4 weeks, and then you would divide it by 4, right, the number of weeks. So we can use this equation here to solve for the sum of hours for the 4 weeks, right? So if you just multiply here both sides by 4, for example, that's a 4, and this side as well. If you multiply both sides by 4, this goes away, so our sum, I'll just put sum for 4 weeks, will be equal to 38.75 times 4. And if you crunch those numbers, you should get 155. So this is good. Now we know how many hours he worked for this first 4 weeks. So we can add on his 5th week, which they said was 42, right? So if we take our 155, add 42 to it, we should get 197. These are the total number of hours for 5 weeks. Okay, so now we can use this to find our 5-week mean. Right? How would we find our 5-week mean? We'd take all the hours for 5 weeks, which we just calculated, 197, and we'll divide it by 5. So all we have to do now is just take 197, divide it by 5, and this will be our 5-week mean. This will be about 39.4. And oops, and that's it. So this problem is all about basically unpacking your mean, right? We have a mean for 4 weeks, but then we have 1 more week to add into it. So we're going to take our mean, unpack it like we did in the beginning to figure out how many hours was it for those 4 weeks. Well, that was pretty easy. We just multiplied both sides by 4. We got 155. So that was the sum for 4 weeks, and then if we add on 1 more week, that 42, that'll give us right here the sum for 5 weeks. And then once you have that, you can just divide that by 5, and that is literally the average for 5 weeks, which we got 39.4. One more problem kind of like this, page 725, number 36. This time, assume you're in some abnormal psychology class and you've earned test scores of 74, 81, 56, and 70, and only 1 test remains. So notice you got 4 tests there. There's going to be 1 more, so there'll be a total of 5 tests. We're just going to do part A here, and it says, if you need to obtain a mean score of 70 to earn a C, then what must you obtain on the final test? So what we want is we want our 5 tests to average to 70, right? That's what they said. That's what they mean by a mean score of 70. And so we need to figure out what is our last test going to be. So I started by saying, let's let X be the score on the last test. Well, how would we find this average? Well, we'd add up all 5 scores, we would divide it by 5, and we would want it to be equal to 70. Well, let's just do that with algebra. We'll take 74 plus 81 plus 56 plus 70, and then plus X. That is 5 scores. And we're going to divide them by 5 to get our average, and we want our average to be 70. All right, so this is our equation, and we just need to solve this for X. It's not too bad to do with some basic algebra. The first thing I would do is get rid of the 5 on the bottom, right? So we're going to multiply both sides by 5. This whole side by 5, this whole side by 5. So over here, remember, the whole point of this is it's going to cancel out with the denominator. I'm also going to go ahead and add up all those scores on the top, the 74, 81, 56, 70, etc. I think you get 281. So when the denominator goes away, you get 281 plus X left over. And on the other side, 5 times 70 would be 350. Right, so already this is a much nicer, much easier equation to solve. If you want to get X by itself, you should subtract 281 from both sides. And 350 minus 281 should be 69. Right, so back to the question. If you need a mean score of 70 to earn a C, what must you obtain on the final test? a 69 or better, right? The minimum score you can get in order to get a C in the class is a 69. So there you go. That's his last problem. Again, you're just kind of playing around with averages, so make sure you focus on what you're looking for, which is X, the score on the last test. Set up what a 5-test mean would look like, add up all 5 scores, divide it by 5, and you want that mean to be equal to 70, and then it just becomes basic algebra to solve for X. Hope this helps. Let me know if you have any questions, and keep up the good work.